All right, so we're back onto an airline kind of profit problem. And it here says the table gives the price in dollars of a round trip flight from Denver to Chicago on a certain airline and the corresponding monthly profit for that airline on that route. So before we do it, we see that the prices are going up. And here we go up, 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 and then it starts going back down. And so what are we seeing? Well, we should say, well, we're seeing some kind of quadratic function. And I think we've had this one before actually with the same kind of numbers and we saw that it was quadratic. Of course, sine function might fit it as well, but the sine function, it's not going to go back up like this again. So I think just the quadratic is going to be kind of the key here. So what we need to do is we need to type this in, and then we need to find the model for the data. Then we need to calculate the average rate of change of profit when the ticket price rises from 200 to 350, and then calculate the average rate of change of profit when the ticket price rises from 350 to 450. Now, notice we could just do that subtraction here, but that's not what we want. We need to find the model first, whatever that curve is, find what, f of 200 is in that model, find f of 350, find f350, find f450, find those values and do our calculations for the average rate of change based on those values, because we're not basing it on this table. We're trying to do it based on the model. Okay. So that's the key. We have to follow the model. All right. So we plug in our data, and as usual, I've gone ahead and done that. So if we go to our graph, I don't know if I said, yeah, I did put that in right. All right. So we have our graph. So now what we have to do is we see again, it goes and follows kind of that quadratic, like I said it should. Now what we need to do is calculate it. So we're going to go to quadratic and do 5, go down. Let's do vars 1, 1. And so this is our function, okay? So let's write that down on my thing so I can put it on the other side. So actually, let's go ahead and now type it over here, or write it over here. So my model, A, it's quadratic, and the model is, let's say, P of T for profit for ticket price. That's going to equal, and it's going to be, or approximately equal to, because we're rounding, negative 0.037 T squared. And then we have plus 25.5 29 uh, T, and then we have minus 57.143, and that's $1,000 profit for T ticket price in dollars, and it's for the T less than or equal to 450, but greater than or equal to 200. Okay, so all that is what we need. Now B, now do I have an extra page so I can put more data? I do. So B, then I'm going to say, okay, well, now I need to use that data, and what that means is I can go to this graph, and guess what? We can do second calc, okay? And we can find our values. And so our values are going to be what we need to look at. And we needed to look at 350. So let's type in 350. And it tells me my value is 350 is 3822.8571. And then I need to find 200. And so then we can go back over here and say, okay, well, 200. Oops, wrong. Yeah, calculate value. And I need 200. And so that is 3081.4286. Now notice both of those are pretty close to what the value was. I think 200 was 3080 and the 350 was 3820 or something like that. But they're very close, but they're not exact. And so that's why we have to use these other values. And let's get that last one. The last one I believe was 450. So let's write that one down. So oops, not 420, 50. And so we need 450 is 3381.4286. And so now let's go write those back on our PowerPoint slide. So I guess we can make a table over here. So we'll have 350 comma 382 2.8571. That's going to be 1 point. We have another point, the 200. That was 308 1.4286. And then we had the 450, and that was 338 1.4286 as well. And see, 3380 3381 4286. So they're close, but they're not exact. But we have to use these calculated values from our graph, because that's what we need to do, because now we've done the model. Now we have to base our calculations on that model. So B was the AROC for 200 to 350. So we're going to have the AROC. And again, so we'll have the F of the first one was 350 minus F of 200 over, and then we had 350 minus 200. Well, 350 was 3822.8571 minus, and then we have 308 1.4286 all over. Well, that's just 150, so I'll just write 150 because I did that calculation in my head. And now that's going to be approximately, now if we do our calculator, then we just plug those in, and we have, looks like we get about 4.943, and that was $1,000, and that's per dollar on the ticket. Okay, so this is kind of one of those weird ones, $1,000 per dollar, because we have $1,000 for every dollar that we spent. Okay, so the ticket price versus the profit. So we're gaining 4.943 thousand dollars per dollar spent on the tickets. Okay, and so that's thousands of dollars of profit per dollar of ticket. So $1,000 of profit per dollar of ticket price. So that's really what it's coming down to. Okay. Now, what about C? C was between 350 and 450. So our AROC here, that's going to be F of 450 minus F of 350 divided by 450 minus 350. All right, so 450 was 338 1.4286 minus 350 was 3822.8571 divided by 450. We'll just write it in, and then we'll just put in our calculator. I didn't simplify it this time. So that's approximately. Now, if we type all that in, when you get this, guess what? This time, we are going to get a negative number here, it shows. And if we think about it, yep, that's smaller than that one. And so a negative number does make sense. So we get a negative 4.414 and $1,000 per dollar. Okay, that's unit, and basically we're going to be losing where that's increase, and this is a decrease. So we are going to decrease $1,000 of profit per dollar of ticket price. And that makes sense because, we're over here on this downside now. And so we're losing our profit as we go. We start here and then we go down here, the profits decreased. And so we're losing on that end down here as our ticket prices are going up. So that does make sense. Okay. All right. Let's pause there and we'll come back for the next one.